Hi, this is a quick video to take you through our lesson on section 9-1 on reflections. So first of all, a reflection is a transformation that occurs when you flip a figure over a line, and this line is called a line of reflection. Each point of the original figure, which is called the pre-image, so think of that as the before, and its corresponding point on the new figure, called the image, and let's think of that as the after, are the same distance away from that line of reflection. So pre-image is before, image is after, and the line of reflection is the mirror. If a point is on the line of reflection, then the image and the pre-image, or the before and after, are going to be the same point. If the point is not on the line of reflection, then what you do is you draw a perpendicular from the original point to the old point, and they'll be equal distances away from the line of reflection on either side. So in this example, we're being asked to sketch the image of ABCD using a reflection in line M. So notice that here is the pre-image, that's the before, quadrilateral ABCD. If I take each point and draw a perpendicular, so notice each of these dashed lines is a perpendicular line through the mirror, through line M. Its image, its mirror image, so notice the mirror image of A is A apostrophe, is the same distance along that perpendicular on the other side of line M. And that same thing would be true about D and D apostrophe, B and B apostrophe, and point C and C apostrophe. And then to finish drawing the quadrilateral, we would just reconnect A to B, B to C, C to D, and then D to A again. So what you should be able to imagine is if I folded the screen along line M, every point in A, B, C, D should line up with every point in its reflection. So the way that we would do this is we draw a perpendicular from each vertex on A, B, C, D through line M, and then we find a point equal distances away on the other side. So if we're going to do this ourselves in number 1 on page 1, I have triangle JKH, and my line of reflection is line M. So what I'm going to do is I'm going to imagine drawing perpendicular lines from each point of JKH to line M. And I'm going to continue my perpendicular line, and then imagine that if I drew a point on the same line equal distances away from line M, that would be J apostrophe, or the reflection of point J. If I do the same thing for point H, imagine again drawing a perpendicular line from point H to line M, and then extending that line through to the other side. And if I draw a point about the same distance away from line M, that would be H apostrophe. K and point K apostrophe are going to be the same point because K is already sitting on the mirror on the line of reflection. And then I will connect J to K, K to H, and J to H again, and that new triangle is my reflected triangle, or the image. And again, imagine folding my screen over line M. The two triangles should overlap exactly. So I've just drawn the reflection. So now in this example, we're working with coordinates. Notice that the letters without apostrophes represent the pre-image. That's the original diagram, D, E, F, G. If I reflect that over the x-axis, notice that it overlaps on itself. It overlaps on itself in this case because there were already points from D, E, F, G that were both above and below the x-axis. It already existed on both sides of that line. If I imagine flipping to the other side of the x-axis, point D, which is 3 spaces directly above the x-axis, will reflect to become point D apostrophe, which is 3 spaces directly below the x-axis. So if I do that for each of the points, if we compare what we get for our new points, compare point D with point D apostrophe. you should notice that the x's are the same, but the y's are opposites. If we do the same thing and we'll compare point E with point E apostrophe, again, the y's stay the same, but the x become the opposites. So what I'd want you to notice from that is that reflecting over the x-axis ended up multiplying the y values by -1. So if you remember that this happens, then when we do problem number 3, we could do that same thing. We could just take the point values for f, g, and h and multiply their y values by -1. I'm more of a visual person, so I'd rather just take each point and imagine what it looks like on the other side of the x-axis. So take a look at point F. If I imagine a perpendicular down through the x-axis, that's 5 spaces away. So point F apostrophe will be on the other end of that line, also 5 spaces away. Point G is 4 units away from the x-axis, so point G apostrophe will be 4 units in the opposite direction. And then point H is 2 spaces below the x-axis, so it's going to reflect or flip to become a point that's 2 spaces above the x-axis. And then I'll reconnect, so F goes with G, G to H, and then H to F. So again, you should be able to imagine that whole original triangle spinning around the x-axis, and it became our new one, our image. And then in our last example, actually we have 2 more. In number 4, we're going to graph the image of ABCD through the line y equals x. So now we're not using the x-axis. We are imagining the line that goes through 0, 0, 1, 1, 2, 2, 3, 3, and so on. Those are all the points where the y is equal to the x. You could also think of it as the line that has a y-intercept of 0 and a slope of 1. So in this case, if I draw my perpendicular lines, so having a slope of 1 will mean perpendicular lines have a slope of -1, and I'll draw that from point C, for example. If I go equal distances away on the other side, I'm going to be at C apostrophe. And then point A, so here's my line with a slope of -1, and equal distances away on the other side gives me point A apostrophe. And then point B and point D will stay in the same place. So those are also B apostrophe and D apostrophe. And then I'll reconnect. So A goes with B, B goes with C, C goes with D, and then D gets connected to point A. So now I've reflected A, B, C, D over the line y equals x. Now what I'll do in the next problem, the original graph isn't given to us. So I have to graph point D, which is -2, -1. Point E is -1, 3. And point F is +3, -1. So that is my pre-image. Now I'm reflecting this one over the y-axis, so this is different from all the other graphs that we've done so far. We will take each of these points and flip them to the opposite side of the y-axis. So point E is 1 space to the left of the y-axis. It's going to flip over to the right side of the y-axis, and that's E apostrophe. Excuse me. Point D, which is right now 2 spaces to the left of the y-axis, flips over to become a new point that's 2 spaces to the right of the x-axis. And then F apostrophe will end up 3 spaces to the left of the y-axis. And then I'll reconnect my triangle, E to D, D to F, and F to E again. So you can see my red one should look like the blue triangle that's spun around the y-axis. So what I want to do before we end is I just want to show you what happens to the coordinates for each of these transformations. So I'm going to write down the original x and y values for A, B, C, D in number 4. Let's see, C is 2, -1, and D is -2, -2. I'm going to show you a comparison to their new locations. So A apostrophe became the point 1, -3. Here's B apostrophe, C apostrophe is -1, +2, and then D apostrophe. And you should notice if we compare everything from the left column to everything from the right-hand column, what happened is when we reflected over the line y equals x, the x and the y coordinates switch places. So just something interesting to observe about that. And then if I do the same thing for number 5, the new D apostrophe was 2, negative 1. E apostrophe became 1, 3. And F apostrophe is negative 3, negative 1. So you should notice if we compare the old points with the new points, what happened here is reflecting over the y-axis multiplied the x values by negative 1.